Hello, welcome to Backer Breaks It Down. In this episode, we continue to look at exponential and linear functions. In our previous episode, we spoke of linear versus exponential, and we wrote functions of the form y equals mx plus b for linear and y equals a times b to the x power for exponential. In the linear function, b is our initial value. And the exponential function, a, is the initial value. In the linear function, m is that number that you're adding or subtracting. So m is positive for addition and negative for subtraction. In an exponential function, b is that number that you're multiplying by. Okay. So we were able to see, like given a table of values, what that number being added or subtracted was, what that that number we're multiplying, what it was. We were able to easily see that. But what if you couldn't? Okay. So there is a way for us to find the values of m and b for our linear function and a and b for exponential function. Okay. First, we have to calculate what I call the change value. So for a linear function, that's the slope. M is equal to y2 minus y1 divided by x2 minus x1. For an exponential function, that's your change factor. B is equal to y2 divided by y1 raised to the power of 1 over x2 minus x1. After you find that change value, you then need to substitute and solve for the initial value. So for linear functions, I'm going to substitute a known point, x, y, my calculated rate of change, m, and I'm going to solve for b, because that's the initial value. In an exponential function, I'm going to substitute that known point, x, y, my calculated change factor, b, and I'm going to solve for a, because a is the initial value. And then finally, I'm going to write the function. So in number 4, I need to find a formula for the linear function shown. So in the graph, the linear function is f of x. Okay. I'm going to use those 2 points. So I'll call negative 2, 6 my x1, y1, and I'll call the 2, 1 my x2, y2. And then I'm just going to follow the steps above, right? So I'm going to start by calculating the change value. That is the slope. So I'm going to be like m equals y2 minus y1. And so that's going to be 1 minus 6 divided by x2 minus x1. So 2 minus negative 2. So I end up with negative 5 over 4. So that's step 1, the value of the change factor, or I should say the change value. Next step is to substitute and solve for the initial value. So I have to pick a point, one that I like best. And I don't know about you, but I prefer this one because it doesn't have any negatives in it. So I'm going to substitute that into the formula y equals mx plus b, and then I'm going to figure out what b is. Okay, so I've already done this work. Okay. And so here we are. I made the substitution. So I have 1 equals negative 5/4 times 2 plus b. I simplified here. So I went negative 5/4 times 2 is negative 10/4, and I solved for b, and I got b is 3.5. Step 3, write the function. So notice I have y equals negative 5/4 x plus 3.5, because m was negative 5/4, b was 3.5. It's easy. So now let's find an exponential function. In the graph over here, that would be g. Step 1, calculate the change value. So I'm going to use my change factor formula, okay? So I'm going to b equals y2 divided by y1. Well, remember, y2 was 1. y1 is 6. And then I'm going to raise this to the power of 1 over x2 minus x1. So 2 minus negative 2 is 4. And I'm going to calculate that, okay? And I'm going to round to 3 decimal places because, well, that's what the directions say. So we're looking at B is approximately 0.639. So that's step 1, find the change value. Step 2, substitute and solve for the initial value. So once again, I'm going to use this point because it doesn't have any negatives, and I like that. And I'm going to substitute it into y equals a times b to the x power. Once again, I've already done this. Okay. So here we are in step 2. I made the substitution. And then I divided to figure out what A is. So this is like the calculation I did to figure out A. I went 1 divided by 0.639 to the second power. I got A is 2.45. And then I write my function y equals 2.45 times 0.639 to the x power. So that's how we find linear and exponential functions when we're working with 2 points. Okay, step 1, calculate the change value. Step 2, substitute and solve for the initial value. And step 3, write the function. That is how Backer breaks it down.